Okay, I think we're back to working. All right, so we're going to keep going with Python. Are there any questions from the last time before we get started? Okay. So we didn't quite finish up with find, so I'm going to do that really quick. So I'm going to log into the ACF. Okay, so I think we had started a little Python script in your directories in the course project. Again, we're not going to be doing anything today that takes any real computational power, so I'm not going to worry too much about us Q-subbing in. So put your user ID, not mine. And then I named my directory Python practice. So whatever you named yours, CD into that. I created a script called hello.py. Now, we have to remember that by default, the ACF is still thinking Python 2. So we check that. 275. We do not want 275. We want 361, I believe. You can always do module avail Python. It's hard to remember the numbers. Module load Python 3.6.1. Now if we do Python version 361. So if you're ever having problems and getting weird errors, if you have forgotten to do that, definitely that could be part of the problem. Okay, so what do we have from last time? I've got this variable called protein. So I've named an empty container. Well, it was empty, but then I assign it to a string. And the string is a sequence of characters. In this case, we use something that looks like an amino acid sequence. I'm printing that string concatenated to the word original. So plus sign when you're doing two strings is not summing, it's concatenating. So it's meshing two things together. And then we learned how to count the valines. So this is a method, the count method. Count the number of bees, and we're printing that count, and then counting the occurrences of the substring VLS. And substring just means like a shorter part of a string, and printing that. It turns out we can also do something called find, and we'll just do it in one giant command. Okay, so we're kind of nesting things again. In like order of operations, you like kind of start at the inner part of the nest and work your way out. So we're gonna take our variable called protein and find the character P. That is going to return an index. And we already talked about like weird indexing in Python. Starts at 0, next character's a 1, next character's a 2. So we're gonna turn that into a string, and then we're going to print the whole thing. So we had 5 V's, we had 5 VLS's, and now it's printing 3, and that could have been kind of hard. So let's see, let's put some text here to help us out. P is located at okay. So if we can double check and see if this actually worked, we have a 0, the V is 0, the L is 1, the S is 2, and the P is 3. So even though normal people, you would count starting at 1, you would think it's a 4, Python likes zeros, so you start at 0 and you come up with 3. And this is just gonna give you the location of the first instance that it finds. You can actually, let's just edit this line and make it a little quicker. You can do more than one character. So find a location where you have both K and T next to each other. And I will change this so that we have an accurate statement. So KT is located at, find the location of KT. So KT is located at 6. So 0, 1, 2, 3, 4, 5, 6. So it's giving us the index of the first character in the substring. So if you had like a whole word, it would give you the index of the first letter of the word. So what if we ask for something that doesn't exist? Ask for W. So in this case, it doesn't return an error, but it gives you a -1. And as we learn more about the language, you can use this to check, does something exist, right? And if you get a -1 back, you know it does not exist in the string. So that's what a -1. It can't return a 0 because the 0 is a thing that it's using as an index. So it will just return a -1, which means that's not available in the string. So that finishes up chapter 2. Count and find are pretty similar. Any questions about count? Yeah.
If you're looking for a character that exists more than once, does it give you like every instance?
I think this one will just return the first one. And if we will probably not get far enough. But the way that I count things is using regular expressions, which you guys are probably sick of hearing. Regular expressions are amazing. We're not going to learn them. But they are really, that's how I would normally do it. But let's see if we add the. I think it'll always just give you the very first. Yeah. And it returns something, so it didn't return a list of locations, it just returns the very first time it finds it. But there is the way to get back a list of all of the places it occurs. And so Python for biologists, like I was looking, and if you make it all the way through those tutorials that are available for free, you can make it like regular expressions are on there. And so we may make it that far. So if we do files and listen loops today and writing our functions and conditional tests on Wednesday, we might make it to regular expressions next Monday, which would be awesome because they're really cool. Dictionaries are also where it's at. If you can make it to the end of dictionaries, you could probably write a third of the most useful scripts that we use in my lab every day. I mean, they're like a lot of like what we do to get output from one program and shove it into another program is just like moving columns around, or like, I don't know, have you guys ever used pivot tables in Excel where you're trying to look up values from one spreadsheet and like move it into another spreadsheet? If you can learn dictionaries, you can do that with Python. So like if we can just make it to the end of this, and if we don't make it in class, if you just like do it yourself, you'll have like a seriously powerful toolkit to do stuff like what you're asking. But let's just start with the basics. Okay, reading and writing files. So this is great, but in bioinformatics, most of the time we have files. We do not have a 50-character single sequence that we want to work with. We've got thousands of sequences. And that means you really want to be able to work with file, both read things from a file and then like output new things to a new file. So that's what we're going to do next. And like I said, this is sort of the core of if you're trying to create a pipeline or a workflow and you're moving from one piece of software to the next piece of software, and like the output from this piece of software isn't quite what you need for the input for this piece of software, like being able to change the format, like being able to write, even if they're like short, kind of simple Python scripts, they can save you so much time and be really powerful. So this is worth learning. So we're talking about text files primarily, or exclusively right now. We've talked a little bit when we looked at SAM and BAM files. Binary files are different. Binary files are completely different beast. none of the methods that we're learning right now are really going to work on binary files. So if you're curious about a file, if it's a text file or a binary file, if you do a head and you see crazy characters that are not English, then you know that's a binary file. If you see words and text that make sense, that's a text file. So what we're learning is pretty much just to manipulate text files. It's worth noting that anything compressed, so if it has a .gz or a .tar or a .tar.gz or .bz2, any of those compressed files are, they're binary, so you need to uncompress them in order to be able to like read and manipulate them in Python. Okay, so I have a file that we can all copy. It is in the software directory, which depending on what your file structure looks like, it is EPP622 software and then inside of there. So hopefully that will work for most of you, or you can give the full path. I have it memorized. It just takes me a second every time. Software DNA, yeah, like that. So either one of those should work. Anybody get permission error? Did that work? Okay, good. Let's just take a look. So this is a super simple, just a little practice file that all it has in it is like 50 nucleotides, nothing fancy to start. Okay, so let's start a new Python script and we'll call it file io.py. So IO is for input output. It's a pretty common like computer science-y IO. So we're learning how to read things in and spit things out, which is input output. So we'll call it file IO. Okay. So first concept, we have to open a file before we can read what's inside of it. So that involves creating a file object. So this is the first thing we're seeing in Python outside of like we had strings, we had numbers. Now we're gonna have something a little more complicated. It's called a file object. And the way we create that is it will have a variable name and we'll use this open function. So open is a function just like print that lives in the Python language. And so we're giving it a file name. It is going to take that file name, go find that file and turn it into an object that we can do things with. Does that sort of make sense? Keep that in mind, yeah. So most of your interactions with file objects will be through methods. It's not really like a string or a number where you would like add it or print it out directly. It's just kind of this abstraction of this thing that lives in your file system, and it's just this abstract object. And so you only operate on it with methods. So most important method is the read method. I would like to read that file. I'm going to create another variable called file contents. So this is going to take my file object and read it. There are more than things that you can do. You can write to files, you can read from files. So we're specifically saying we want to read this file. We want to take the contents and stick it into a new variable called file contents. And then again, we could run this right now, but it wouldn't produce any output, right? Like this is just like having a regular string variable. Okay, great, you've got a variable, now what? Well, one of the things we could do to ensure that, you know, we believe that this is working is print it out. I'm gonna save that. All right, I printed out the contents of my file. This does make the assumption that dna.txt is in the same directory as your Python script. If this was in a different directory, it wouldn't work. Okay, so this is generally what causes a lot of confusion, is understanding the difference between a file object and the file contents and a file name, all of which you can put into different variables. So for example, we could say my file name is dna.txt. that is just a regular string literal. So that is just a string until we use it to create a file object. So my file object will open my. So my file name, the string that represents this set of characters, we're going to use that as an argument to the open function. The open function is going to go look for, okay, great, I know that there's a dna.txt file. I'm going to go find it and create an object and assign that object to the variable name my file object. And then we could have my file contents just to be totally consistent. So my file name is a string, just like the strings we worked with last week. My file object, we have used that string as an argument to a function. It has created an object. It is not a string. It is a file object. And then from that, we are calling the read method. The read method returns a string. So we're back to another string, and we're assigning that to the variable my file contents. So one of the most common mistakes I see when people are learning Python is they're trying to do, they get these three things very confused. And they try to directly read from the string that is the file name instead of from the file object, or something like that. So let's make sure I don't have any typos. Yes. Oops, and I can't spell. Okay. Okay, and we're back to a working Python file. Okay, so let's see. So you can only use the read method on a file object. So what if we tried to read the file name? So we tried to do that. String object has no attribute read. So what that is telling us is that my file name, it is just a string. It is not a file, it's a string. So you can't read from it. So I mentioned last time that methods are attached to a specific type of thing. So the count method could only be used for a string. In this case, the read method can only be used for a file object. Does that make sense? Oh, the other thing you can do that is common is instead of printing the contents, you could try to print the object directly. So, and this seems intuitive, right? Like I have a file object, I should be able to print it. I should automatically print the contents, but that's not actually what it does. So let's see what that does. It gives you some stuff that doesn't make sense. And basically, but this is giving you a glimpse under the hood of the language. So the file object is not a string. The file object has all this stuff going on. The file object includes the name of the file. It includes the mode, which we're about to learn about, but it's saying this file has been open for reading. So the mode is R. It has the encoding of the file, like how is the file like what is this underlying coding in the system. It's UTF-8, which is a character encoding. So the file object has all this stuff going on under the hood. And it's nice because you don't actually have to know about any of that. It just means that if you try to print it, you get something that doesn't necessarily make a lot of sense to you. Instead, you have to read the file. The read method will give you a string, and then you can print the string, if that makes sense. Okay, new lines. My file contents. Okay, so we have opened the file, we've read the contents, we can calculate the length. Let's visit how to do that. I'm gonna change this. Okay, so I'm gonna print out the sequence, which comes from my file contents, and I'm also gonna print out the link. The length is 52. Okay, so you may be wondering, why do we have this extra new line between seek is and length is 52? Because we didn't put a new line in there, right? We didn't put an extra new line. So print always adds a single new line, but we've got two, right? It goes down and then it goes down another one. And I used too long of a sequence for this to be obvious, but this is actually 51 nucleotides. So there's an extra character. So what do you think the character is? Yes, so it's a white space character. It's a new one. So the string is stored in the computer. Not going to be great. You guys all see. Is, for example, so what it's storing is like A, C, G, T /N. So it's storing 5 characters. Even though you don't see the /N, it's just printing it as a new line. So if we ask for the length of the string, it would tell you 5 instead of 4. Because the computer thinks of that as a character that it's storing. It's storing bits to represent that new line. But there's an easy way to get rid of them. Oops. There's something called rstrip. So you can use it, okay, let's call fixed equals contents dot rstrip. Let's say print. We'll call it f length. Okay, so we're creating a new variable called fixed. We are going to take our string, my file contents, and use the method rstrip, which stands for strip off of the right end of the string. Not surprisingly, there is also a left strip. You can strip off of the front of a string. We're saying if there's a new line on the end, strip it off. If there's not a new line, this will return the same string. From there, we are going to take that new variable called fixed, find the length, assign it to a variable called f-length. To prove to ourselves that this has all worked, we are going to print the new sequence and the length of the new sequence. So this time we get the sequence printed out. It looks exactly the same, but we're not getting that extra new line. It's stripped off that new line with the rstrip. And the length has gone down to, this is actually the correct number of nucleotides in the string. It's 51, not 52. The other thing we can do, sort of a common way to do this, delete all this stuff, is to chain commands together. So we can just say read.rstrip like that. So we talked about when you have nested parentheses, you start inside and move outside. If things are nested with dots, you read from left to right. So this is take the file object, read it, take the results of that read, and strip the n off, and then return whatever is at the end of that whole statement and assign it to my file contents variable. And now we have the correct printing and the correct length, assuming that we don't want the new line. It's going to go ahead and work correctly with the R strip at the very end. So what happens if we try to open a file that isn't there? Let's do file IO2. This is actually a pretty useful error, file not found error, no such file or directory. So you could probably decipher that. I think and we saw this a little bit on the command line, people who were getting errors. I start at the bottom of the error and then go up. Like the most useful information is almost always at the bottom. And so if you have a program that spits out like 200 error lines, I start at the bottom. And then you can move your way up where it gives you the actual line, and then it gives you the file. And traceback, so traceback just means it's going back. It's when something fails, it tries to go backward in time and figure out during the course of execution of the program what failed. Super simple here because we have one file with a few lines of code. If you had some big piece of software with lots of files and lots of moving parts, it might trace back through multiple threads of execution and give you a whole bunch of stuff. But getting used to reading error messages is helpful. Okay, so let's talk about writing. So we've learned how to read a file. We're going to use the open function again, but this time we are going to open it with another argument. So let me delete this. We're going to do out.text as our first output file. So when you open a file, it has modes. So the first one we saw, we didn't specify. So the default is to read. If you don't tell Python what you want to do with a file, it assumes that you want to open it for reading. If you want to open a file for writing, you actually have to give it another argument, which is the W argument. And there are a couple of different modes. So W is a good one to know because that means I want to write to a file, useful. A is append. So this is very much like, you know how we learned the single greater than and the double greater than? And one was like to completely overwrite a file, and the other one would just append to the bottom. Same concept here. A W means write to the file. If it already exists, get rid of it and start fresh, overwrite it. Whereas an A means just add to a file. Don't destroy anything that's already there. So it's a bit of a safer mode if you're concerned that you might overwrite something you care about. And this is a great, so if you forget all of this, you can always Google Python 3 open, for example. Let me make this. And I just wanted to point this out. Well, sometimes, actually, if I don't do Python 3, if I just do Python open, I got the 3 documentation ahead of the 2 documentation, but be careful when you're going through documentation because all that Python 2 documentation is still out there and it may or may not be conserved in Python 3. So try to make sure that you see like a 3 somewhere. You can always just add a 3 when you're Googling and that'll help you. This gives you all of the built-in functions. We've seen print and now we're looking at open. If you click on open, you'll find out there are lots of modes. Read, write, and append are pretty much the only ones that you're going to care about. And one of the reasons to learn this from a simple, easy to understand book, like Python for Biologists, is if you try to parse through this, it can get very confusing very fast because there's lots and lots and lots of different ways to do everything. But it is also a really good resource. So if you're not sure how to do something, they have really good documentation out there. But we're only going to really care about read and write for this class. But it's good to be aware that there are other things out there. Okay, so not surprisingly, just like we had a read method, we're going to have a write method. Again, we take the file object. The object has a method. The method takes the argument of what you want to write. Okay, so it didn't give us any output this time. But if we look, we now have a file called out.txt. So Python was smart enough to say, okay, you want to write to this file out.txt. It does not exist. I need to create that file. And then we do cat. We see that there's a hello world in there. You see how it like didn't push my prompt down to a new line? So it didn't print a new line because we didn't tell it to. This is sort of an interesting non-intuitive difference between print and write. When you print a line in Python, like print it to the terminal, it's always going to add a new line at the end automatically. If you write, write does not automatically add a new line. We can go fix that by adding a new line. Like that. And now we have our nice new line and our prompt shows up where we want it to. Oops, nano. Okay, another thing that we can do to files is close them. And the previous part of this lesson, I was opening files and I was reading from them and I was not closing them. That's not very good practice. Not closing a file will not cause a problem 99% of the time, but the 1% of the time it does cause a problem. It can be difficult to debug and figure out what's going on, and you can end up overwriting other files. Again, typically not a problem until you're writing somewhat more complicated programs, but it's good to just start closing files, like just get in the habit that when you open, you close. At the end, it doesn't return anything useful. It doesn't do anything obvious. It's not going to put anything in command line. You're going to have no idea like that it's even there. But it's good to put it in there because there are occasions when you leave a file open and things accidentally get written to it, or you just want to close it and say, I don't want to work on this file anymore. So the other thing for open, you can put the full directory path here. So let's say we have been getting dna.txt. So let's say we wanted to put the full path to that. I'm going to go get the full path. So, let's even say that you just didn't want to copy it to your local directory. We know there's a version in the software directory. So it didn't print anything, but it didn't complain that the file didn't exist. So now we've proved to ourselves that we can put, indeed, the full link or the full path to a file, and it will find it, and you can still read it in, and you can still print the contents. Okay, So one of the big problems with what we have learned so far is that we're reading all of the contents of the file into one giant variable. So let's imagine that that file had 10,000 lines. Would it be particularly useful for us to have a single variable with all of that data as one big, long, giant string? And the answer is usually no. Usually you want to parse your file line by line. So that's one of the things that we are going to work on learning next. And the other thing that we need to learn to do that, so two concepts we're going to need to learn to do that, lists and loops. Loops you're going to enjoy because you've seen them before. You've seen a for loop. You know what that looks like. But lists we have to do first. So let me get out of here, and I'm going to start list.i. Okay, so a list is just like it sounds. It's a list of things. So we could do something like use square brackets to make a list. And we're going to make a list to start. We're going to make a list of strings. Like that. So the variable name is fruit. Fruit is not pointing to one thing. So what we've seen in the past is a variable could point to a single string, it could point to a single number, it could point to a file object. What it's pointing to now is a whole list of things. So it's a list of individual strings that are stored in this kind of like superstructure that we're calling fruit, the fruit list. Lists can also be numbers, sites, any old random list of numbers you want to do. And we can print. So the first thing, you can print an entire list by coercing it to a string. So we learned this str, that you can put a number inside of str and it turns the number into a printable thing, turns it into a string. And that's called coercion. I don't know if I said that last time. You can coerce something from one type to another. So this str method will also coerce a list to a string. Actually, I don't know what happens if you just try to print it without coercing it. Maybe it prints fine. Yeah, it prints fine. Okay. Well, if you ever need to turn it into a string for some other reason, you can coerce it. Print's a pretty smart function. It knows how to print a lot of things without coercion. Anyway. But if you wanted to print a single item, you can use an index. So using the square brackets again, if I put sites, square bracket 0, close brackets, that means give me the element that has the index 0, which in this case, we always start counting from 0, so that should be the number 1. So we get back our element. We could also do fruit 0, we'll change it to 1. So we expect this to be orange. Apple has the index 0, orange has the index 1. We want to print the fruit, the item from the fruit list that is at the index position of 1. So this should look very similar to what we learned about for strings, printing the elements using an index in a string. You can assign individual parts of a list to a variable. So you could say fav site. My favorite site is sites 0, 1, 2, 3. It's the number 2. And that'll work just fine. So I did not coerce it, and it's a number, so we have to go force it to be a string. Oops. Does that make sense? So I pulled out the fourth item from the sites list. The fourth item has the index 3. It was a number, it was an integer. And so I tried to print that integer, and it said, no, 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 I don't know how to print integers. Or I don't know, it's because it's the plus sign, because I don't know how to add a string and an integer together. That's a nonsensical thing that you have asked me to do. And so you, in this case, you would convert your integer into a string or coerce it. And then it says, oh, okay, you want to concatenate those two things. I can do that, and then it'll print, if that makes sense. Oh, if you have a really long list and you want to get the last item, you can use -1. So last fruit, -1. Last fruit is lemon. Okay, so now let's do something really fun. I love the skepticism in that laugh. So this is how I think it actually makes sense to program. I'm going to open up another terminal and SSH to the ACF again. And you can continue on with using a single terminal. That is fine. But I'm going to show you how I like to program because I think it just makes your whole life a lot easier. So I'm going to keep editing up here. So let's do list2.py. And let's do, oh yeah, let's do ranges. Ranges are fun. So notice this time I was lazy and I didn't put spaces after the commas. That doesn't matter. That's okay. No big deal. Python doesn't actually care. Like sometimes spacing matters and sometimes it doesn't, and sometimes you just have to learn which is which. But inside of a list, as long as you have your commas, it will be fine. The ranges work pretty much just like we learned last time with the colon. So this is saying going from index 2 to index 5, numbering from 0, 2 is inclusive, 5 is exclusive. So we'll include the element at index 2, at 3, and at 4. We will not include the element at index 5. Okay, so why did we open 2 terminals? Okay, so this I'm gonna hit Control-O and write it out, and then down here, what did I call this? List2.py. And I didn't complain. I need to print it out if we want to actually see what's in there. So Control-W, oops, Control-C, Control-O to write out, and then I can run it. Class order family. So at this point, I can be editing up here and just saving the file and then running down here. So I don't have to keep like closing the file and running it and reopening the file and closing the file and running it and reopening the file. This is just, I'm always going to keep the file open up here and I'm always going to be running the file as executing it down here. And so that just makes my like fix an error, execute, fix an error, execute. It just makes that whole cycle a lot faster, which I think is worth it. And it also means that I can show you things without having to print everything out. So in this case, kingdom was 0, we didn't print it. Phylum was 1, we didn't print it. Class to family all got printed. So if I change this to 4 and control it, you can see in this case we did not order, even though it's 0, 1, 2, 3, 4, inclusive of for the 2, exclusive for the 4, so it didn't print family. So this is actually, this is an insight into how Python stores strings. Strings are actually a list of characters. So all of the things you can do to a string as far as like using these square brackets to get substrings and to get ranges and to get individual parts of a string, that's because it's a list. It's a list of characters, if that makes sense. So when you have a list of something else, a list of whole strings, it's a list of lists, but don't worry too much about that. If you have a list of strings or a list of numbers, those square brackets are going to work exactly the same. What did I forget? Okay, append. We can append to a list. So, oops. So now genus has been added. Okay, so this is a really interesting, this is an important distinction about this method. Many methods, like we saw count and we saw find, they do not change the nature of the object that they are attached to. This method changes ranks, which may be obvious, but it's important to be aware, like some methods change the object they're operating on and some don't. In this case, it is going to take ranks and permanently append genus to it. Like when you exit this statement, when you move to the next line, ranks now has a new element. So it is not going to return a list with genus added. It actually modifies ranks itself. Does that make sense? Instead of like getting something new back and assigning it to a new variable, it is changing the nature of the thing that it is attached to, which is worth noting. What else? We learned about -1 to print the last thing. Oh, length works as well. Len ranks. We say length of ranks is take ranks, find the length, turn it into a string. Invalid syntax. Parentheses. Yep, I missed one. So there's actually this great concept in learning how to program, or in programming just in general, to do pair programming, where like one person's the person typing and someone else is just sitting beside them, kind of like thinking about the structure of the program or looking for errors. Because like when you're writing it yourself, it's really hard to see all your errors, but someone beside you will just be like, oh, you're out of parentheses, or oh, you should make that a fine, you know, like, and it's this really powerful way to learn, but it's also professional coders do it all the time where they pair up and it just makes for better, better coding. I've always thought we should do like pair writing. We have to sit down and write a paper as a pair, because like one person would be like trying to write the sentences and somebody else would be finding all the grammar mistakes and looking up the citations, and like how great would that be? I don't know, if anyone ever tries it, let me know. I'm convinced it would be awesome. So yeah, so you guys, if you want to practice, that might be a good way to practice, where like one person is reading the Python for Biologists and the other person is doing the typing, you're kind of going back and forth, learning how to program. I think that would work really well. Okay, you can also concatenate two lists. So ranks, more ranks. Yes. Jeez. Actually, let's just name this something. We'll name it all ranks. So in this case, concatenation works very similarly to what we learned with strings, where it's just mushing them together in the same order. The left one stays on the left and the right one stays on the right, and makes one nice new list that we can store into all ranks. There are reverse and sort, which are both really useful when you're working with lists. So reverse is another one of those methods that intrinsically changes the object. So we did reverse, and then we printed all ranks, and the list has changed. The list is now in reverse order. So if you did something like all ranks, square bracket, 0, before reverse, and then did it again after reverse, you would get two different things. And you can also sort. And in this case, we're now getting a nice little alphabetical sort there. So fun with lists. Okay, so now that we have lists of things, the fun thing to do is to do the same thing to every item in a list, right? Like, talk about this. This is very exciting for shell programming because you can take 1,000 files and say, do the same thing to every file. Well, the same concept here. We can have a list that is virtually infinitely long, and we can write a small piece of script and say, do the exact same thing to everything in this list. So that I don't have to go through and do it manually, is usually the goal. Let me delete all of this. What do I want to start from? I'll just get rid of all of this. Okay, for rank in ranks. Yeah, rank. Okay, so this is kind of like the for loops we've learned with a little bit different syntax. So you remember I talked about like, oh, if you learn one programming language, you're like 90% of the way there to learning another programming language. Well, that 10% turns out to be syntax, which by I just mean like punctuation and structure. So in this case, we're still going to start with the word for. That is the same. The variable goes next. So the variable name is rank in a list. So when we learn this for bash shell scripting, we're usually generating a list of files. But in this case, we've already created a list. And then new, instead of the word do, we're going to use a colon. From there, the body of the loop must be indented. If you do not indent it, Python will give you an error. There is no, Python knows that the end of the loop has come because the next line isn't indented. So every line that is indented is considered to be inside the for loop. And every line that, and then if you had another line like here, that is not inside the loop because it is not indented. So white space in Python matters. So let's see how this works and we'll keep talking about that because it's kind of different than most languages. Okay, so we have our ranks list. We say for each item in the list, call it the variable rank, print whatever it is on this iteration of the loop, and then is a rank. And this is not the most pretty list because I need a space here. Okay, now reads a little better. And when I print high, that is after the end of the loop because it is not part of the loop. However, if I hit tab and put it there, oops, I always want to hit Control W as cancel. It prints high as part of the loop. So it says, okay, for rank and ranks. So I'm gonna iterate over the list ranks. Rank is equal to kingdom the first time through. So print kingdom is a rank, print high. In the next iteration, rank is phylum. Print phylum is a rank, print high, et cetera, until you get to the end of the list. So very much like bash programming, but again, like there's no done. The done is completely based on this indentation situation. Python is very particular about spaces. You can use a tab, you can use a set of spaces, but you cannot mix and match. So let's say here, and I've been using tab, which some Python programmers will tell you makes me the devil. There are many people who believe that four spaces and only four spaces is the only way to do it. I just always hit tab because it's faster. So what you can do and what you're quote unquote supposed to do is get a text editor where every time you hit tab, it pastes in four spaces. So that everybody in the world, all of the code, like it looks the same on everybody's computer because a tab is always exactly four spaces and this tab character is not actually being used. Nano isn't that smart, so I'm just hitting tab. But at this point, I have a tab here. So if I hit the left arrow and the right arrow, you can see it's only a single character. Whereas here, I've got spaces, and they're lining up, and I think this should totally fail. Let's see what Python has to say about it. Actually, I liked it. Okay, a different number of spaces. And I think this might be the real problem, is that some people's computers, the tab is like 4 spaces, and sometimes it's 5, and sometimes it's 8. Okay, let's see how it likes that. Okay, indentation error. Unindent does not match any outer indentation level. So it doesn't like this because it doesn't match. So everything inside the loop, and like once you start a precedent at the top of your Python script, you have to carry through with that level of indentation. Like if you decide a single tab is going to be your indentation, you have to use that everywhere in the program. If you decide it's going to be 4 spaces, you need to use 4 spaces everywhere else in the whole piece of code. So in this case, I'm going to change this to a tab. So when you hear people say Python white space matters, that's what they mean. Most other programming languages actually don't really care about white space. And there's like a curly bracket to begin a for loop and a curly bracket to end a for loop. Like that's how Perl would do it. But Python, it's supposed to make it much more legible because you don't have all these like crazy curly brackets all over the place. It makes it very clean. Like if you've ever written in another language, this is a very clean and satisfying and minimalistic kind of language. And that's why it's done. But it does mean that paying attention to indentation is something you have to do. Okay, so we can do all kinds of things in loops. Length. Equals. Actually, oops. Okay, I bump this down, bump that down. Okay, so inside of our loop, I'm going to take this rank variable, I'm going to get the length, stored in a variable called length. I'm going to get the first letter, because it's just a string after all, right? Like the string kingdom or the string phylum. So I can get the first letter using our square bracket 0. I can print rank, what iteration are we on? I can print the length of that, and then I can print the first letter. Kingdom is a rank, length is 7, first letter is K. So I forgot to put a space, but first letter is P, first letter is C. So I could go back and fix that. See, like as long as I keep indenting these lines, I can build up all the stuff we want to do to all the items on our list. Oh, and we can do this with strings. So, I'm piling up a lot of different Python files. What are we going to call the next one? We'll call it a string list. Let's say Albert. So I can I mentioned that a string is itself just a list of characters. So you can operate on it with a for loop and parse the characters. And it'll go through, and each character will be each little individual character in the string. And so you can operate it on it like a list. So strings are a list of characters, I think is the take home there. Another thing we can do, which is pretty nifty, is split a string to make a list. So let's say we have three names and they're divided by commas. And what we really want, let's say these are, we could say they're species. We could split. So species, we want to create a real list. So at this point, name is just it's just a string. A string is a list of characters, but if we actually want that to be 3 strings, a list of 3 strings, we can split it. So this is saying, let's take our string. We have a method called split. Everywhere you see a comma, split the string up, and then return to me all of the substrings and store them in a list, name, species. In this case, we could say for individual species in species, in this case, we have to manage to take, so this is great, right? Because you sometimes get Excel spreadsheets that have comma separated values and you want to split on a comma and you want to turn things into a list so that you can operate over all of the parts of that line. So that's pretty nifty. And of course, the easier way to do this would be to just print species. And that will prove to you that it is indeed being stored as a very typical list. So that split method returns an item of type list. So it's important when you're learning about methods. Methods they operate on a type of thing. They take arguments that are sometimes types of things, and then they return types of things. And all of those can be different, right? So this one, it has to be attached to a string. It takes another string as an argument, but it returns a list. So whenever you're learning about a method, all of those things can be different, right? Like the thing it's attached to, the argument, and the thing it returns can all be completely different objects and different types of things. So you have to be really cognizant of like what different variables are and where to use where. Yep, so you can, I don't have a file ready that has, here, let's go create one. So I'm gonna create a new file, text, and we'll put in 3 lines. Now we can say, just open a new file. So we opened the file, we iterated over each line in the file and printed them. So this is how we're starting to get to the point where you can iterate over a file. And if you had a file with lots and lots and lots of pieces and you wanted to do something to each line, you would now be able to do that. Ooh, okay, another fun, let's go back to our protein example. No, not there. What's the first thing we try? Hello. Okay, I'm just gonna copy that line. And we'll call it hello 2. That line. So I just want a line to start with. So this is kind of not the most compelling problem because you might not actually want to ever do this. But let's say you wanted to print out the first 3 residues and then the first 4 residues and then the first 5 residues. I'm kind of building a pyramid. You could do that with something like this. 3, 4, 5, 6, 7. Imagine that going on, and for stop and stop positions. Okay, so we have created a list of all of our stop positions. We're going to iterate over that and say, for each of our stop positions, take from 0 to stop, store that as a substring, and then print it. So what we're hoping is we'll print the range 0 to 3. So 0 would be B, 1, 2, 3. So we'll get BLS, again, inclusive, exclusive. And then the next time through the loop, we'll get 0 and 1, 2, 3, 4. So let's see how that works. What do I call that? Hello 2. Proteins is not defined. So we've built this loop up so that we can iterate over these stuck positions. But there's a better way to do this, and that's to use a range. So we can delete this. So range is this great little function that if you say range 3, 8, it returns a list that's 3, 4, 5, 6, 7, 8. So you don't have to type all of those things out. So it automatically kind of understands like, oh, you want, range means you want all of the numbers in between these two numbers. And it still works. So range is really nifty. Another thing you can do is count by, like, let's say we wanted to count by 2. So instead of giving us 3, 4, 5, 6, 7, 8, this should give us 3, 5, 7, and then it'll end. And we can stop it. I always forget. Oh, stop is a integer. It doesn't like to try to concatenate a string in an integer, so we have to coerce it back to a string. So 3, 5, and 7. So does that make sense? The first argument is the first index that you want to start counting from. The second argument is the last one you want to end. So if you wanted 1 to 10, you would get the numbers 1 to 10. And then the third argument is the step. So if you went from 1 to 10 stepping by 2, you would go 1, 3, 5, 7, 9, and then you'd be done. Does that make sense? You can step by 4, you can step by 10, you can step by whatever you want. But range is really nifty for being able to just create ways to like iterate over things without typing a lot of numbers. All right, that is all we're going to do today because that's a lot to absorb. We're a little bit early, but that's good. What I really recommend is going through and trying to do the exercises. So if we go to the book, which I think I had open somewhere. Yeah. And it has very nice documentation. I used some different examples, but they're pretty much the exact same thing as what they have in the book. It's great to go through and read this and to try to do all of the exercises, but where you're actually going to really learn and kind of ingest the knowledge is scroll all the way down and find the exercises. I'll do the exercises essentially as a homework. You will have a homework that is going to use the same concepts. But in the meantime, if you're looking for more practice, this is a great place to start. Basically, they want you to buy the book to get the solutions. But if you would like to see the solution without buying the book, come find me and I'll print off the PDF pages for you. Although buy the book. Like, I do feel kind of guilty that I use this book and don't get anyone to buy it. The poor author gets no proceeds. But so I do recommend the book. But if you just want to see the solution to a couple of these exercises, I do have the PDF and I can get that to you. What was that? Do I have a copy? When I bought it, I just got the PDF version, but I don't know if they sell it as a physical hard copy book. I assume if you get on Amazon, they do. Let's look. I don't have the hard copy. Yeah, maybe the library has it. You could look. Oh, paperback. Yeah, so you can get the physical book if you want it. Any other questions? All right, stay after if you have any questions about the homework from last week. And I will have tests graded by Wednesday. I'm almost done. You guys write a lot, but it's really good. Good job. I want all my tests to have drawings and emojis because those are hilarious and wonderful, and that was my favorite part of grading, so thank you. All the people crying as they were using the ACF was great. It really cracked me up.